Welcome students to session number 5. We are going to study the very first topic in this session is indirect methods for measuring small distances. Last time we have discussed large distances. Now we are going to discuss small distances. Indirect methods for measuring small distances. In this topic we have to study Avogadro's hypothesis, how to measure the small distances at nuclear level. The very first topic is atomic radius by Avogadro's hypothesis. Atoms are spherical in shape, everybody knows. Atoms are spherical in shape. Atomic radius by Avogadro hypothesis we are studying. Atoms are spherical in shape, that everybody's know. So when a large number of atoms are packed together, some empty spaces are left, between them. When atoms are tightly packed, you will be able to see there are voids, that are spaces remaining between the atoms. So according to Avogadro's hypothesis, he said that the volume occupied by the atoms in 1 gram of substance is 2/3 the volume occupied by the substance 1 gram substance. Clear? Means 1/3 portion is being occupied by what? Empty spaces or voids between atoms. According to Avogadro hypothesis, the actual volume occupied by the atoms in 1 gram of substance, 1 gram of substance is two-third of the volume of 1 gram of substance. Clear? Means you can say actual volume of atoms in 1 gram of substance, that is equal to 2/3 of its total volume, 1 gram of substance. Clear? That means 1/3 of the volume of 1 gram of substance is occupied by the empty voids, empty spaces between atoms, or you can say by voids. Clear? 1/3 of the portion is being occupied by what? Empty spaces or voids between atoms, and actual volume of atoms in 1 gram of substance is 2/3 of its total volume of 1 gram of substance. Let m be the molecular mass of a substance, then m grams, then m grams of the substance will contain in bracket Avogadro's number of atoms. Yes or no? That everybody knows. In one molecular mass, how many atoms are containing Avogadro numbers of atoms? Till this clear? Therefore, number of atoms, if I want to calculate number of atoms in 1 gram, that is equal to what? Avogadro number divided by what? Molecular mass. If R be the radius of each atom, if R be the radius of each atom, then volume of atoms in 1 gram, volume of atoms in 1 gram, that is equal to what? Number of atoms, that is n by m, and volume of one atom is what? 4 by 3 pi r cube. Clear? This is nothing but what? Volume of one atom, and n by n is nothing but what? Number of atoms in 1 gram, 1 gram of substance. Yes or no? Till this clear? Now moving ahead, let V be the actual volume, V be the actual volume occupied by molecules in 1 gram of substance. Then by recently we have said Avogadro hypothesis. What Avogadro's hypothesis told? Actual volume occupied by the atoms, n by m dot 4 by 3 pi r cube, that is equal to 2/3 of its total volume V. Yes or no? 2/3 of its total volume V. Now we know that if rho is the density of substance, if rho is the density of the substance, then density is equal to what? Mass upon volume. Density is equal to what? Mass upon mass. We can take 1 gram, volume we can take V, density is equal to 1 by V. Till this clear? Or from here you can say V is equal to what? 1 by rho. V is equal to 1 by rho. Clear or not? Now moving ahead, we have recently derived that V is equal to 1 by rho from density is equal to mass upon volume. Mass we have taken 1 gram, volume we have taken V. So we got an equation rho is equal to 1 by V. From that we can derive V is equal to 1 by rho. Clear? Now we can put into the equation, that is m by m, number of atoms into volume of each atom, that is 4 by 3 pi r cube, that is equal to 2/3 of its volume. So I can write that n by m into bracket 4 by 3 pi r cube, that is equal to 2/3 volume. Instead of volume I can substitute what? 1 by rho. I can substitute from here, V is equal to 1 by rho. So from this I can get the equation for R, that is R is equal to m divided by 2 pi n rho whole cube root. I can get whole cube root. I can get. This is how I can calculate the radius of what? Atom. Thus the radius of atom of substance can be determined. Clear? This is how you can determine the radius of a atom of substance. Clear? Moving to the next topic, how to determine the molecular size of folic acid. molecular size of oleic acid. How to determine molecular size of oleic acid? Clear? Now moving ahead, oleic acid is a soapy liquid with large molecular size. Large molecular size. Oleic acid is a soapy liquid with large molecular size. We dissolve, now listen carefully, we dissolve 1 centimeter cube of oleic acid. We dissolve 1 centimeter cube of oleic acid in 20 centimeter cube of alcohol. We are dissolving 1 centimeter cube of oleic acid in 20 centimeter cube of alcohol. If somebody asks concentration of the solution, then you can say 1 by 20. Yes or no? 1 centimeter cube of oleic acid in 20 centimeter cube of alcohol. You can say concentration of oleic acid in this alcohol solution, you can say 1 by 20. And then redissolve. We are redissolving the solution and then redissolve. 1 centimeter cube volume of the solution. This solution means solution of oleic acid and alcohol in parts 1 by 20. This solution of 1 centimeter cube we are dissolving in 20 centimeter cube of alcohol. 20 centimeter cube of alcohol. First we have taken 1 centimeter cube of oleic acid in 20 centimeter cube of alcohol. Then this solution, we are taking 1 more centimeter cube of this solution, we are again dissolving into 20 centimeter cube of alcohol. Then the concentration of oleic acid, if somebody asks, then concentration of oleic acid if somebody asks, is what? 1 by 20 into 1 by 20, that is what? 1 by 400. Yes or no? Then the concentration of oleic acid is 1 by 400 centimeter cube of alcohol in 1 centimeter cube, you can say in 1 centimeter cube of alcohol. Clear? What is concentration of if somebody asks, then what is concentration of this solution oleic acid in alcohol at present, then you can say it is 1 by 400 centimeter cube in 1 centimeter cube of alcohol. Till this clear? Hope it is cleared. We then determine the approximate volume. We then determine the approximate value, of volume, approximate volume of each drop we consider to be V centimeter cube. Now pour n drops of solution, Now we are taking this solution and we are putting drops of the solution into water. N drops of solution on the surface of water, taken in a broad vessel. Here we are taking water in a broad vessel and then pouring n drops of the solution, in which you can say the concentration of oleic acid is 1 by 400 centimeter cube in 1 centimeter cube of alcohol. Clear? Now in broad vessel we are taking water and we are pouring n drops of this solution. We stretch the film carefully. As we are exposing this solution to air, alcohol will evaporate. Yes or no? As alcohol evaporates, as alcohol evaporates, as alcohol evaporates. Yes, a very thin film, a very thin film of oleic acid, a very thin film of oleic acid is left on water surface, is left on water surface. Till this clear? We measure the area A of the film using graph paper, using a graph paper. Now we can calculate the volume of n drops of what? Solution. You can say n drops, and volume was each drop was having volume V. So total volume will be what? NV centimeter cube. Yes or no? Number of drops and volume of each drops. Number of drops and V is what? Volume of each drop. Yes or no? Till this clear? So the total volume of drops will be what? NV cube. Now if somebody asks what is amount of oleic acid, in this solution, if somebody asks amount of oleic acid in this solution, what you're going to say? N by 400, because concentration of oleic acid 1 centimeter cube of the solution is what? 1 by 400. So it's N by 400 into volume V centimeter cube. So our answer is how much? NV divided by 400 centimeter cube. Till this clear? Now if somebody has thickness of this oil film, if somebody asks, what you will mention? Denoted by T, thickness denoted by T, that is equal to what? Volume of the film divided by area of the film. Volume of the film, what is the answer for volume of the film? NV divided by, if we need to determine the thickness T, that is equal to what? Volume of the film divided by area of the film. Volume of the film we already know, that is NV divided by what? 400 centimeter cube, and area, that is A, that we have measured using graph paper. So my answer is what? NV divided by 400 A centimeter. That would be my thickness of the oil film. Till this clear? Assuming that the film has one molecular thickness, if you are saying, then T will be approximately size or diameter of a molecule of oleic acid the value of T is found to be of the order of 10 power minus 9 meter. Remember, the value of T found for the oleic acid experimentally was found to be 10 power minus 9 meter. Is this clear? 100%. Now moving to some example related to this. Before that, we'll study few formulas used for solving such examples. The very first formula, that is molar volume. Molar volume, that is nothing but volume of 1 mole of gas at STP. What is STP? Stands for standard temperature and pressure. Standard temperature and pressure. Yes or no? Is found to be that everybody knows that is 22.4 liters. You have already studied 22.4 liters. Second, volume of sphere. For atom you will use as what? Atom is considered to be spherical, so volume of sphere is what? 4 by 3 pi r cube. Third, if somebody asks us thickness of oil film, that we have recently derived the formula. Thickness of oil film, that is equal to what? Volume of oil film. Volume of oil film divided by what? Area of oil film. Till this clear? Volume of oil film divided by area of oil film. Till this clear? Now next we have to see V, that is always measured in centimeter cube. R, we have to see that it should be in meters. If it is in centimeter cube, this would be in centimeter. If it is in meter cube, then you have to use R into meter. Sometimes volume is given in liters also. We have known that N, that is nothing but what? Avogadro's constant, or you can say Avogadro's number. The value for N is how much? 6.023 into 10 power 23. Till this clear? 1 Armstrong, that everybody knows, that is 10 power minus 10 meter, and 1 liter is equal to 10 power minus 3 meter cube. Remember, 1 liter 10 power minus 3 meter cube, and 1 Armstrong 10 power minus 10 meter. Till this clear? Now let us take some example. The radius of muonic hydrogen atom is found to be 2.5 into 10 power minus 13 meter. What is the total atomic volume? Total atomic volume in meter cube of a mole of such hydrogen atoms. Clear? So here they have given radius to us. R is equal to what? 2.5 into 10 power minus 13 meters, and they are asking volume of 1 mole of H atoms. They are asking to determine volume of 1 mole of hydrogen atoms. Now for further solving this numerical, we know that volume of one atom is what? Volume of one atom, that is 4 by 3, because it is considered to be spherical. It is 4 by 3 pi r cube. Till this clear? Now number of atoms in 1 mole. Number of atoms, I can say H atoms in 1 mole. In 1 mole of hydrogen, how much? It's like Avogadro number, that is capital N. That is what? 6.023 into 10 power 23. Till this clear? This much. So I can write as volume of 1 mole of H atoms, that is equal to number of molecules into 1 mole of H atoms into volume of each atom, that is 1 by 4 by 3 pi r cube, and is 6.023 into 10 power 23 into 4 by 3. Pi is 3.14, and radius was given in the question, that was 2.5 into 10 power minus 13 cube. Till this clear? Now I am going to solve with the calculator. See, first I am going to multiply 6.023 into 4 into 3.14 divided by 3 into 2.5 3 times, 1 time, 2 time, 3 time. Till this clear? You are going to get 394.00. 394.00 into 10 power, I have to check 23 is over here, 13 threes are, that is how much? Minus 39. Till this clear? So what I'll do, 394 to 10 power 23 minus 39. So I'm going to get is minus 16. Yes or no? Minus 16. Unit will be meter cube volume. If I shift 2 position to the left, 3.94. Left means plus 2. Yes or no? So answer is 3.94 into 10 power minus 14 meter cube. Hope till this clear. Next question we are going to see example. A drop of olive oil of radius 0.25 mm spreads into a circular film of radius 10 centimeter on the water surface. Estimate the molecular size of the olive oil. Molecular size of olive oil. Recently we have studied the formula for thickness of oil film. That is equal to what? Volume of oil film divided by what? Area of oil film. Yes or no? For volume of oil film, 4 by 3 pi r cube, they have given 0.25 mm. So mm you have to take it what into 10 power minus 1 to centimeter. Yes or no? Cube divided by area. Circular film they have taken. Area circular film. So what? Pi r square. So pi radius 10 centimeter. No? 10 square. This is centimeter cube and this is centimeter square. Cut centimeter. Pi also cut. So your answer is 4 by 3 into 0.025 cube divided by 10 square. Now using calculator, how will able to get 4 into 0.025 into 0.025 into 0.025 divided by 10. So your answer is how much? Divided by 3. So your answer is 0.00000000060200833. Clear? If I'll move how many positions? 1 2 3 4 5 6 7 positions. Clear? Towards right. So 2.0833 into 10 power towards right means what? Minus 7. Yes or no? And unit will be what? Centimeter. I can write assuming that the film has one molecular thickness, then molecular size of olive oil, is equal to 2.0833 into 10 power minus 7 centimeter. Hope till this clear.